Hi, let's go over a rational function where y equals to x minus 3 plus 2. So the first thing I'm going to want you to do is to look to see the denominator, what makes the denominator undefined, what value for x would make the denominator undefined. So we could see if we plugged in 3 for x, we would get 0 in the denominator. So we have a vertical asymptote at x equals 3. So x equals 3 is our vertical asymptote. And what is our horizontal asymptote? Well, you can see here that if this fraction can never be 0, then y can never be equal to 2. So you can look on the horizontal along 2, and we can see that our horizontal asymptote is y equals to 2. So what does this mean? It means that the graph, if you look at x equals 3, the graph is approaching 3, but will never touch 3. So from the right, as I'm moving towards the left, you could see it approaches 3, but never touches 3. And when I come from the left, I am also approaching 3, but will never touch 3. So we call that a vertical asymptote, or horizontal asymptote is y equals 2. I also want you to find x and y intercepts. So you can look at the graph to see where does the graph go through the x-axis. So you can actually see right here at the point 2.5 comma 0 is an x-intercept. So we have an x-intercept at 2.5 comma 0. Also, the way you can find it is if you plug in 0 for y and solve for the equation, you will get 2.5 for x. So you can see that when x is 2.5, y is 0. Now, what do you think the y-intercept is? Well, let's take a look. Right here, the y-intercept is 1.667. So a y-intercept is when x is 0. So if you look at the equation here, if we were to plug in 0 for this value, okay, 1 over 0 minus 3 is negative 1/3, and 2 minus 1/3 would give us the value that we see right here, 1.667. So we can write the y-intercept is when x is 0. Y is, well, if you wanted to write 2 minus 1/3 and write it as 2 minus 1/3 is 1 2/3, that would be the same as 1.667 or 1.67, you could say approximately. So we have our vertical asymptote is x equals 3. Our horizontal asymptote is y equals 2. We have an x-intercept right here, as you can see, at 2.5 comma 0. We have a y-intercept when x is 0 at 1.67. Now let's talk about the domain. The domain, when you look at our restriction, we have a vertical asymptote here. So that means the domain you can write it as x is an element of all real numbers. So this means that it represents all real numbers except x cannot equal 3. So you can see the dashed line here. This is our vertical asymptote at x equals 3. That means the graph cannot touch that line. So the domain and asymptote are related in a sense where whatever the asymptote is, the vertical asymptote, that's what the domain cannot be. So let's look at the range. Same idea for the range. The range is y is an element of all real numbers. So y is an element of all real numbers where y cannot equal, what do you think? I'm trying to make a double R here. Where y cannot equal 2. So y cannot equal 2. So if you look at the graph, again, We have a horizontal asymptote at 2. That means the y will never be 2. So the y is never going to touch the line y equals 2. So therefore, our range is y cannot equal 2. And in the domain, we see we have a vertical asymptote at x equals 3. So the domain is the set of all real numbers except x cannot equal 3.